Welcome, my dear students in Prep 2. Our session today is about intervals. We will continue intervals. Our session today is about operations on intervals. Do you remember sets? The operations on intervals are the same as on the set. Let's revise some operation on sets. For example, if we have three sets, x, y, and the universal set, x consists of 3, 4, and 7, y 1, 2, 3, and 4, and the universal set 1, 2, 3, 4, 6, and 7. I want to calculate x, or I want to determine x intersect y, x union y, x difference y, and y difference x, also x dash and y dash. Let's begin with the intersect. X intersect y, it means the common elements between x and y. So we have 3 and 4, because 3 and 4 found in x and also found in y. So the intersect means the common elements between the two sets. X union y means all the elements. So I write all the elements of x and y, but without repetition. X difference y, it means elements found in x but not in y. Elements found in x but not in y. So I write 7. 7 is found in x but not in y. Okay, what about y minus x or y difference x? It means the elements found in y but not in x. Yes. Okay, so 1 and 2. So the difference means elements in the first but not in the second. Okay, x dash, it means the complement of x. Okay, all the elements except x, all the elements here in U except x. So we have, I'll cancel 4, 7, and 3, and I write all the other elements, so 1, 2, and 6. By the same way, y dash, it means all elements except y. So I remove y from the universal set. I'll cancel 1, 2, 3, and 4, so I write 6 and 7. Okay, so complement means all except the set. Okay, let's continue. Here we have two intervals, x and y. Interval x is from -3 to 3. Let's draw. From -3 to 3, this is -3, and here we have 3. So this is x from -3 to 3 and closed at -3, closed and at 3. Y from -1 to 5. This is -1 and this is 5. But it's opened at 5, so I draw open circle at 5. This interval is the wanted interval y. I want x union y. X union y means all the two intervals. So from here to here, from -3 to 5. Open or closed at -3, closed as we can see, at 5 open. So I write this region from -3 to 5 because I want x union y. It will be from -3 to 5 and open at 5. From -3 to 5 opened at 5. Number 2, x intersect y, the common region between the two sets. So from negative, the region which consists of blue and red, the two sets. So from -1 to 3, this region. Okay, opened or closed, here at -1 closed, and at 3 also closed. So this is the intersect interval. X difference y, it means elements in x but not in y, so I want only the blue color. so this region. Okay, I write negative 3 and negative 1. Okay, I want elements belongs to x but doesn't belong to y, so I'll open at negative 1 because negative 1 is yes in y. Okay, so it will be from negative 3 to negative 1, closed at negative 3 and opened at negative 1. The last one here, y minus x. It means elements belongs to y but doesn't belong to x. Look at here. So the red region only. So from 3 to 5. Okay, at 3 I want elements. Any element doesn't belong to y. Sorry, belong to y but doesn't belong to x. So here 3 belongs to x and y. So I'll open at 3. 5 also doesn't belong to y, but 5 also doesn't belong to x. So it will be opened at 3 and at 5. Okay, so 3 and 5. So y difference x means elements belongs to y but doesn't belong to x. Okay, another exercise. If x is the interval from 1 to 4, closed at 1 and opened at 4, y equals the set of 1 and 4. I want to determine x intersect y, x union y, x difference y, and y difference x. The first step is to draw. So I draw the number line here, 1 and 4. The interval x is from 1 to 4, opened at 4, so this is x. Y consists of only 2 points, 1 and 4. So this is y. Okay, x intersect y, it means the common between x and y, which is only 1. So the set of 1. X union y, it means x and y together. So I start from 1 until I reach 4. So from 1 to 4, opened or closed. 1 belongs to x and y. Also, also 4 belongs to y. So I'll take 1 and 4 and all the real numbers between 1 and 4. So it will be closed interval from 1 to 4. Number 3, x difference y, it means elements belong to x but doesn't belong to y. Let's see here. So it will be this region belongs to x but not to y. So this region from 1 to 4, opened or closed, doesn't belong to y. So I'll open at 1. Okay, and also I'll open at 4 because 4 belongs to y. So it will be the open interval from 1 to 4. Y difference x. What are elements found in y but not in x? We have only one element, which is 4. Yes, so the set of 4, not interval. Another exercise. Here we have x is the unlimited interval from negative infinity to 2, y negative 1 and 5. So I'll draw. This is the first interval x, and here from negative 1 to 5. So this is interval y. I want x dash and y dash. X dash, it means all the elements, all the number line except x. The universal set here is the set of real number. So if I want the complement of x, it means that I want all the number line except x. So I write from 2 to infinity. Okay, 2 from 2 to infinity. This is the interval. Or I can write it as in another way, r minus x. R minus x, which is negative infinity to 2. Or I can write it as 2 from 2 to infinity, closed at 2 because 2 doesn't belong to x. Y dash means all except y. So I have two parts. The parts from negative infinity to negative 1 and the other part from 5 to infinity. Or I can write it as r minus y. R minus y means r minus negative 1 and 5. Okay, or the two intervals. The first one from negative infinity to negative 1, this interval. I want all the number line except y, so I remove y. If you remove y, you have two parts on the number line. The first one from negative infinity to negative 1. Okay. But negative 1 opens because it's already found in y. By the same way, the union, the second part, is from 5 to infinity, and also 5 belongs to y, so I'll open it at 5. Or you can write it as r minus and write the set or the interval y, negative 1 to 5. Okay. Okay, that's all about our session today. We will continue next session, operations on the real number. Thank you very much for watching and goodbye.